Cool. All right, guys. Well, what we kind of do on this is just any sort of like feedback, any constructive feedback. I'm always trying to make this better. So, don't be overly polite. If you've got any suggestions where things can be improved, don't hold back. Just tell me.
Is it standard for the schematic in certain way to relate pages to pages?
So these arrows, they indicate the direction of the cable.
Yeah, so see that tear symbol? Is that the same on all schematics everywhere in the world? Like,
No. I've seen that on some designs. That's why I've used it. I quite like it.
Yeah. And what it like, as in like BMS, building management system, what are you using there? Like SCADA?
Yeah, so you wouldn't necessarily refer to it as SCADA in a BMS. It would be referred to as an HMI. Now we got to imagine that all the wiring's been done and we're commissioning it. So we can't really. Cool. All right, guys. Well, what we kind of do on this is just any sort of like feedback, any constructive feedback. I'm always trying to make this better. So don't be overly polite. If you've got any suggestions where things can be improved, don't hold back. Just tell me. I'll note them down, and there'll be things that I bring in if I think they're sort of worthwhile and they're not going to take ages to do, and other people are mentioning them. Then I'll be improving it over time. So yeah, any feedback, just let me know. Whether it's on the live call, whether it's email, DM, whatever. Just let me know. That'd be great. So firstly, what we do is we go through questions. We've got about an hour, and I've got another call just gone 9, so I need to keep this to an hour. So we go through questions. So any questions that you're keeping note of, we go through that. I'll share my tablet, and we go through the schematics. And then what we do as well is we go through the first scenario. I know, Gary, you've been through it. It's good. I don't think anyone else is. Oh, Ben, you've been through it as well. So yeah, good stuff, guys. There's a few of you that have been through it, so we'll review that together. Josh, did you go through it?
No, I haven't. I just downloaded the downloads last night, and I did like the first introduction page. Yeah.
That's all right, mate. I just couldn't. I saw that you sent me some WhatsApps, but I couldn't respond, so I couldn't remember whether it's one of the WhatsApps was your scenario. Right, so I'll share my screen.
yeah, Josh, if you're having trouble like finding time to do the training, the modules that you've been downloaded, just don't have any sleep, mate. Don't go to sleep. Just do it then.
Yeah. I only signed up to the course yesterday, so I downloaded all the files yesterday, and then I'll get started on it tonight. But yeah, they're doing fire alarm testing here in a minute, so I might need to put it on mute.
I forgot to tell you the other day, Josh, that you actually slipped through the net. So we had 15 people, which was like, all that keeping it to 15, and you managed to slip through. So yeah.
Oh, nice.
It's good to have you. But we got 16 people on this.
Oh wow.
Nice. Anyway, guys, can you see my tablet and the schematics?
Yep.
Yep.
Yeah, I've got it, mate.
Great. Okay. So, Federico, let's go with you first, mate, because I know you got a few questions.
I have questions. So this was my second week, and I kind of just finished it.
Yeah.
So since last Wednesday, I was starting to, I've been writing questions in all different pages. Mm-hmm. So if it's okay if I go through it.
Let's what we do. Let's cover two.
Let me remember the situations that because some of the questions answered later on the training. So
let's cover two of your questions initially, and then we'll see if anyone else has got questions.
I think it was one in general.
Okay.
Is that isn't it standard for the schematic in certain way? to just to relate pages to pages, this is out of the general, right? I'm saying with the signal goes out to the PLC, you know that you have two arrows.
Yeah.
It's just a general question. Exactly. If the arrows wouldn't help having the direction of the electrical flow.
So these arrows, they indicate the direction of the cable, not the flow of electrons.
Perfect.
Because that's all we're drawing in the schematics.
Yeah.
It's the cables, right?
It was just a question. The general thing. In the schematic, so you said in one of the videos, the schematic that for the Wessex unit,
Yep.
yeah, that we have to adapt it. And who's the job to adapt the Wessex and in the when it comes to the specs or the design?
So just so everyone's up to speed, so the Wessex is the manufacturer of the boilers. So that's what you're referring to there, right, Federico?
Yes.
Okay, so ask the question again.
Like and we cannot follow the specs, right? To run out to the unit.
I don't understand. We can't follow this?
When we wire when we send the signal out, right? There's the Wessex have different settings in the device. Do we just follow the spec and who is involved or who's supposed to approve the setup for it?
Who's meant to approve? Sorry, I'm not understanding.
How do we set it up? Just following the specs?
What, the boiler?
Yes. So to know the connections that we're going to make.
Yeah, so that's really, yeah, in the spec. So
Okay.
if I remember off the top of my head, it does detail that it needs to be a 0 to 10 volt control signal. Even if it doesn't, it does say in the spec that we need to sort of modulate the heat of the boiler. So in some of the sections of the spec, it says that we need to bring the boilers up to temperature, and then bring them back down and sort of level them off. So just the language that's used there, it kind of indicates that it needs to be a 0 to, well, it needs to be modulated, so not just on or off. And typically the way to do that on boilers is an analog signal. So analog signal is going to be like a range, so 0 to 10 volts or 4 to 20 milliamp. Typically the analog control signals that are usually used. In this case, the boiler has that additional module that we need to clip into it. Sorry, no, we don't use the additional module to clip into for the analog control. That's just for the volt and enable output. The boiler natively has that H1, and again, now we're looking at the tech manual. So the tech manual will show you that we've got H1 input, and that can be used either for a 0 to 10 volt control signal, or it can be used as just an on-off signal. So to answer your question, mate, to find that out, it's in the spec and in the tech manual.
I think it's a 7.05, but I think we have from 740 or something like that. That's why on the specs.
You'll have to I don't know the spec off the top of my head. There's too much to it, so you'll have to tell me what you mean by that.
I think that I couldn't find the spec on that side, on that part.
You can't see the spec anywhere in the resources folder. It's in there. I'll show you where it is. Let me show you that now, just so everyone's clear. Can you see my Google Drive here? Cool. Yeah, so what you guys, so this is the folder that everyone has access to.
Yeah.
MCP, this is kind of the folder that I put together. Like, this is pretty much a typical project folder that I will construct over the life cycle of the project, with all the necessary details. So that's the MCP. We'll come back to that. These are just images of the panel progression. So I think this is just helpful. Like, as you make your way through the pages, you can sort of see what we've done in terms of like the physical wiring of the panel, step by step. And also you've got access to the completed panel at the end, where you can see all the labeling, and reference what's in the schematic. So like, let's just take a relay R6, for example. If you wanted to actually see what that looked like physically in the panel, we can find an image and we can zoom in and we can see that, here we go, here's R6. That's the relay that we're looking at here in the schematics. And you can do that with every element, every symbol within the schematics. You can then pull up those images and reference it. So you're building up an actual picture in your head of what that looks like in terms of physical hardware. So those are the images. The next folder, existing old system. So that's because this is a real project where we refurbed, we basically upgraded the BMS in this school. So there is the original system, if you wanted to look at that, some images and whatnot, and the old schematics, old tech manuals, that's there. And then construction issue. So construction issue, and I'll put brackets from the M&E specifier. So this is what I received from the electrical contractor that came to me to help with the BMS and the controls. This was what was issued to them from the M&E specifier. So this is kind of all you get to work from initially. So we got the spec, we got the equipment schedules, they sent the original BMS schematics, and then we've got the sort of like hydraulic schematics here with all the pipe work, floor plan of the plant room, and sort of a bigger floor plan with again like the heating system pipe work. The spec, Federico, is here. It's redacted, and I've split. This spec was huge. It had like all the data for every single trade that was on this project. So I've just split it to the pages that are actually relevant to us as control engineers. And I've highlighted important bits. So that's the original spec that you can go through. And then I've split that even further, because this is how I do things. I kind of just split things to like it can't be split anymore, and it just allows me to focus on just the things that are relevant to me as a controls engineer. So I've done that even further, and I've put that into the MCP folder. Let me just remember where it is. It's not in there. Drawing pack. Yeah, so drawing pack, MISC, yeah, school refurb, spec notes, electrical design. So yeah, this is probably the one that you want to look at, mate, because there's not too many 7 pages. I've highlighted sections in red that are focusing more on the programming. So when we actually get to the programming stage, these are things we need to be aware of. And then the sections highlighted in blue, they're key things that we need to be aware of in terms of the electrical design and the panel build. It's all important information, but those, I'm just picking key bits out there. So I'd recommend reading through that. Everyone, if you get sort of 5-10 minutes, just have a scan through that, and that's what you will get from an M&E designer. That's kind of what you've got to work with. Does that answer your question, mate? I know it's long-winded.
No, yeah. it's I think that specs it's on 705 and the thing start from 720.
705. 705.
It's something like that. But it's I think it's irrelevant. It's kind of like you actually give it more details and explain us how everything comes to be the way it is. So
Send me a message, mate, if you want to go into more detail in this, and
yeah, and I think that the rest, nothing. It was a question about the 0 to 10 and 4 to 20 milliamps. When do you use either or? But you answered in another almost at the end.
Yeah.
So it's pretty obvious. And then another extra little question is like, what happened when you change devices when extend the limit distance? You know that the specifications for many, you say pumps or probes, they in the specifications said that you cannot extend them more than 30 meters or 20 meters in some of them.
Yeah. You're talking about the cable run.
Yes.
Yeah. So you've got to be a bit careful and wary of very long cable runs, or so just that in general, that's something to be aware of, just because signals over a long stretch of cable diminish. Think about things like voltage drop and whatnot. I think you're referring specifically to the PLC, the PLC signals,
or when it sends the 0 to 10 volts in order to increase or decrease the temperature.
Yeah, so just generally speaking, like when we're on the PLC section and we're looking at analog signals, so like the analog signals coming back from the pressure sensors, going out to the boilers, those mainly. Pressure sensors, temperature sensors. Yeah, there's temperature sensors up here. Yeah, you just got to be careful or make sure that you read the manual, RTFM, read the fucking manual, and it will make a recommendation on how long that cable run should be. It will probably be okay if you go a bit over that, but they're just, that's the recommendation. If it's longer than that, then you might start, it will affect the signal, basically, in a nutshell. So it's just something to be aware of. Again, it's just the importance of reading the manual, gives you all of this information and detail. So just one thing you take away from all of this, if you're going to start doing controls, to understand a system, understand a piece of equipment, read the fucking manual, RTFM. And that that's not to you, Federico, that's to everyone. Any piece of equipment will have a manual. So you might have to Google it, you might have to search online for it, but that's how you understand how to sort of put together and design a system, partly.
And then, well, thank you for those. And I guess that's pretty much it. I have maybe other questions that I put out.
Let's see if anyone else has got any other questions, then we come back to you, buddy. All right. So I know a lot of you guys are fairly new, you haven't been through much of the training yet, but thus far, like, have you got any little questions that are cropping up that you want to go over?
Yeah, Chris, can I ask a question, please?
Yes, mate.
Yeah, so one of them anyway was what the other guy was saying, Frederic, about the arrows. Obviously, that's not flow direction, that's just telling you where the next page is, yeah? And another one was just the tear you call it.
Yeah.
Obviously, you don't number the end of that, and we're just assuming that it seems like that's just basically on the immediate next page where the tear is. Yeah, always. Yeah.
I know what you mean. That hasn't been clearly specified that is the case, but if it's kind of, it's not obvious, but it's kind of intuitive, because if you do then move to the next page, It's like, oh, that tear links, it like the puzzle is then connected, and also it's labeled the same.
Yeah, so see that tear symbol? Is that the same on all schematics everywhere in the world? Like,
No. So that's you. I've seen that on some designs. That's why I've used it. I quite like it.
you can't confuse it for any other symbol, though, no?
No, this isn't really like a standardized symbol. This tear symbol. It's just kind of just a way of drawing and indicating that, because I haven't got enough room on this page here really to sort of, I mean, I could have moved this down here, but I want to kind of keep things tidy. So if you kind of run out of room, and you're drawing it in this style, that's just me showing that there's more to this. There's more to this gas detection system, but it's over this way, which actually means it's on this page.
Yeah, so I'm not like what all I'm saying is I'm not going to get that symbol confused with any other symbol, am I? It's straightforward. Isn't it?
No, it's
Nice one, mate. That's good, Chris. Thank you.
I just said, but in, I've never seen that on any other schematic I've looked at on any firm. That's the first time I've seen that.
Have you seen or have you worked with many BMS systems?
Not particularly, but on like machine schematics and stuff like that. So it could be kilns, it could be anything. Like whether it's German, Spanish, and then I think German have got a different technical language as well. So some of the words when translated aren't very good. But yeah, that's the first time I've seen the tear symbol.
Yeah. So I've never seen this on industrial projects. Like designers tend to design things slightly differently, like industrial projects compared to like BMS projects. Also, you've got to be aware of like what is drawing the system. Is it someone just manually on CAD drawing it bit by bit, like what I've done in this project, or are they using like an automated software like ePlan, SolidWorks Electrical, one of those where, yeah, it basically draws it all for you. In that case, they typically use those automated softwares or bigger firms use them because they're doing projects every day, typically industrial projects. So what I'm saying is, in most industrial projects, you won't see it drawn like this. Yeah, it will be slightly different. Schematics are, yeah, like I said, it's down to the designer, how they lay it out. It's down to the software, how it's laid out. So they are all going to be a little bit different. You might also see some schematics sort of drawn where rather than having these feeds up the top, you might see them coming down the center here.
Yeah, I've always seen the tears on schematics in my line of work, but I've never actually seen this one that you're doing now, the centre one. I'd like to see one of them, see what sort of what difference there is.
So you might have like inputs on this side, and then you might have outputs on this side. So schematics are drawn differently, but the principles behind it, it's all the same. So if you can sort of understand a system on one type of schematic, then it's the same principles across all schematics. It's just drawn in a slightly different way. It's like I use the analogy of interpreting handwriting. Some handwriting is harder to understand. Some's easier, some's more clearer. So yeah, it's the same thing. Everything's the same. It's all electrical controls, but it's just laid out differently, really. You said you've seen tears on other projects, did you say, Gary?
Yeah, I've seen quite a few schematics over the past years, and I've seen them. I've seen them around. Yeah, so they are used in a lot of schematics. You do see them. Like I think Paul Lyons was saying that he's never really seen one before. But they're slightly different. They're slightly differently designed, but they do mean the same thing. Basically, you go from one page to the next. You know what I'm saying?
Yeah.
So they
Yeah,
are.
I mean, if Paul's mainly been around industrial projects, then it's less common in industrial projects. This is kind of a BMS thing. Maybe it's like, you know, BMS designers like using this little way to draw it, and the fact that we've drawn things in this style where let's get rid of those lines on the sheet. Because we've sort of laid it out in this way where everything on this line, well, everything south of that line is out in the field, everything north is in the panel. This kind of layout I've seen a few times before. And then the fact that we're drawing things like in blocks. Yeah, sorry, I'm going off on one, but I think it's more common in BMS projects that you see it drawn like this, basically, is what I'm saying. Sorry, rambled. Does anyone else?
I might ask a question as well.
Yeah, go for it, mate.
Yeah, this is the first time I've had a look at this, and you zoom in and out of on like some specific parts of it. But do you mind giving us a quick overview of like what this project is, like what it's doing? Like, is it a boiler or heater or something? Did you say? And yeah, we got power at the top and your safety circuit.
Let me get. So this is
the first time I've had a look at it.
Yeah, well, this is basically what we do throughout the whole training. So I won't go into details, but I'll give you a good sort of conceptual overview of the project. And the best way to do that is looking at these issued schematics from the M&E designer.
Oh yeah, sure. Yeah, that's what we had up before. Yeah.
So you can see that we're doing heating control in a school. So you can see this is obviously the school here. We've got our plant room over here. You can see all the pipe work. Ultimately goes back to this boiler plant room. Now, if we go, now that's kind of like a floor plan overview. Now, this drawing here is the schematic, is the hydraulic schematic. So if you're doing any heating systems, like whether it's commercial or domestic, and you won't tend to get this off just a domestic plumber or heating engineer. But if I'm doing any controls, even if it's a small smart home project, I want the heating engineer, the plumber, who's actually designed the heating system and the layout and the pipe work, I want them to do me something like this. Like, it doesn't have to be as professional like this and done on CAD. It can just be, you know, like just drawn in pencil, piece of paper, and then photographed and sent me. But I need to know as a controls engineer, like how it's piped up, where the pumps are, where the valves are, etc. I need that overview to understand it. So I don't make mistakes, basically. And going off on one again, just an important thing to note, guys. So make sure you always have a hydraulic schematic from the heating engineer. You know, don't continue with the project unless you get this. Like, this is super important. It's going to save lots of confusion and balls ups later down the line. So basically, mate, you can see that we've got two circuits.
Chris, that was about my question about the drawings and what happened when the design specifications indicate for one kind of probe to put, for example, in the pumps.
Federico, let me just finish this point, mate, and then we'll come back to what you're saying. So this is the plant room, and you can see this sort of grey box indicates what is in the plant room. We've got two boilers, so we're controlling the boilers. We've got main incoming gas, so BMS, we're going to be controlling the gas on and off based on certain conditions. We've got, if we look closer, we've got our boilers, we've got our pumps for each boiler, we've got T for temperature sensors, P for pressure sensors. So this is what's known as the primary side. So the primary side is like when you're looking at a heating system and you've got a low loss header, this is referred to as the primary side, and then the secondary side is the other side of the low loss header, where you can see we've got more pressure sensors. We've got these two pumps here, like a duty standby arrangement, Josh, like we were talking about yesterday.
Yeah.
Pretty common in commercial industrial premises, like where it's critical that you don't, like if something goes wrong with one of these pumps, we can just switch over to the other pump and we still got heating, hot water, whatever. And in that time, or as soon as it goes into fault, we can be made aware of it, or the client can be made aware, and we can come and fix that pump whilst the other one is running. And we're never without heating, hot water, as we talked about yesterday, mate. You've seen that before. You've worked on pumps like that.
Yeah.
And then ultimately, we've got two circuits. We've got a kitchen circuit, and you can see here, this is just just a heater coil. So like a can't
Heat
think of
exchanger.
with a coil and a fan. So that's one circuit, and you can see it's coming off the low loss header here. The second circuit is this massive circuit going to all the rooms, heating circuit going to all the rooms in the classrooms, and they're made up of radiators indicated by an R or a OD or ODH, which indicates an over door heater. So again, like a fan coil unit, like up in the kitchen. So that is a big picture view of the project. Now, I'm not going to go into any more detail than that really, but then the M&E designer, the mechanical electrical designer specifier, then writes in the spec what they want you as a controls engineer to do with this system, like timings, how boilers should fire up, if something fails, what should happen, etc., etc. But it's pretty, if you get one spec from an M&E designer for a BMS system, and then you've got another project and you get a spec from another M&E designer, they're all pretty much the same. When you get into BMS controls, it's pretty standardized how you do things. Obviously, there might be more pumps, there might be more valves, that you might be controlling slightly different equipment, but the principles are pretty similar.
Yeah. And what it like is, as in like BMS building management system, are you like, what are you using there, like SCADA?
Yeah, so when you say SCADA, just so other people know what we're talking about, it's kind of this thing. So we've got like a big picture graphical overview of the whole system. Yeah, so you wouldn't necessarily refer to it as SCADA in a BMS. It would be referred to as an HMI, which will have kind of SCADA stuff on it. So basically like a tablet on the front of a control panel. So this project that we're working on, it will have an HMI on it, but at the moment we're just focusing on the actual electrical control side rather than the programming of the PLC and the HMI. But it does have one. Yeah, you'll have a graphical overview of this project.
Yeah.
Any other questions, guys? Cool. All right, what we do, let's just run through the first scenario. Now, I know some of you guys haven't been through the first scenario, so maybe you don't want to see me run through it. If you want to test your own knowledge before seeing me run through it, and then we can go through it again on the next coaching call.
I'm happy for you to go through it now. Sure.
Okay.
Yeah, like as long as the others are.
But just a heads up, if anyone doesn't want to see it, I'm going to go through it now. So maybe you want to, I don't know, shut off your camera, mute me, or leave and join us on the next one. It's entirely up to you, but I'm going to run through that now. So the scenario was, you've got to site, you're sort of installing / commissioning the system, and the client sort of done a last minute change, and or hasn't, it's not the client that's changed it, but the client's asking, would it be possible to have an e-stop in the reception area? So the receptionist, if she feels there's a problem, maybe she's hearing noises and stuff, and just isn't unsure of something, she just wants to be able to hit the e-stop and it shuts the system down. Now, in a real project, it's probably unlikely that the plant room's going to be within 20 meters of the reception area, but just play with me here. So that's the idea behind this scenario. So we want to add an additional e-stop to our system, but still have exactly the same operation. Now, the guys that I've had images back from who've done this, they've all done it very well. So yeah, this is really for everyone else. So ultimately what we need to do in this circuit here, so this is our like EM emergency stop circuit from the gas detection system. And guys that aren't at this place and don't fully understand the gas detection system, it's covered in the training. So just go with me here. I'm talking to the guys that have already been through the training on this page. So ultimately all we need to do is add an additional e-stop that we've got here into this circuit here. Because you can see it's all it is just a series circuit, and the e-stop here is normally closed, and then we're going back into the panel and then out of the panel, and now we're going to our boiler thermal links, and you can see that they're normally closed, so just keeping that circuit in series. This is out in the field, back into the panel, and then we're going back here. This is obviously a bit of cable, and then we're going back to our gas detection system and completing the circuit. So that's what we're looking for. And then as soon as something goes open circuit, like one of the links above the boiler's gone or someone's hit the e-stop, that's an unhealthy condition. We can then do things off the back of that, and there's a problem. Basically, it's an unhealthy condition. So we want to just add an additional e-stop. Now we got to imagine that all the wiring's been done and we're commissioning it. So we can't really tap into we can't really affect the wiring that's already there. That's not really good practice. So what are we going to do? The best way to do it, let's remove that. This is what I would do, and this is what I've seen some of the guys that have sent me their scenarios back have done, which is great. I would get another couple of terminal blocks from the van. I would add them in here. This is the panel. Don't worry about the labeling. That's not important of these terminal blocks. Then I would install the e-stop. Forgive my drawing. I would install the e-stop at the reception area. So that's on the wall. Okay, that's on the wall there. Then I'm going to wire this e-stop in. So I'm connecting my 2-core cable here, back to the panel, and here, back to the panel. So that's out in the field now. Now we just need to work this into this series circuit that we've just talked about, which then ultimately goes back to the gas detection system. So what wiring mods are we going to now do in the control panel? And it's really simple. What I would do is this cable here, I would just remove it from terminal block 9 here, and just put it into this terminal block here. So we're removing that and we're wiring it into here. That's the first thing. That's nice and easy. So that's ultimately no longer there. And then where that cable was, we're adding another bit of cable out of here into here. That's it. So now let's just quickly go through that circuit again. So we're coming out of the gas detection system into the panel, out of the panel to our first E-stop, back in the panel, out to our thermal links above the boiler, back in the panel, and then out to our new E-stop in the reception area, back into the panel, and then back to the gas detection system. Simple as that, guys. Everyone happy with that? Does that make sense?
Yeah. Is that just single channel?
How do you mean, mate?
Like on the E-stop, is it just like a single channel E-stop? So it's just
Yeah.
so
Yeah.
it's, you know what I mean? Instead of your dual channel relays and stuff like that.
Yeah. So again, this is something that in industrial environments where you're using things like safety relays, where it's safety critical, like there's moving machinery that can ultimately kill people, then in safety circuits that are using safety relays, you need to add that additional redundancy where you have like two contacts on the E-stop and they're working together, so you might have like a normally open and normally closed, and you hit that and it inverts both of them, but then back at the panel, the safety relay needs to see sort of both of those change at the same time to tell it that it's working okay. And if it doesn't see that, then there's a problem and it shuts down the system.
Yeah. It's just redundancy and like different levels of redundancy.
Yeah, exactly. And so in a BMS, you don't see, even though I refer to a safety circuit, it's important not to confuse that with a safety relay. And I'll just so you guys are aware, let me just show you what a safety relay looks like.
Yeah, they usually come under the machinery directive. Hence that's where you'd get the standard from.
Yeah. And it's all determined through a risk assessment, ultimately, if you need to use a safety relay. There's you do the risk assessment and in a BMS project, and it never warrants the need for a safety relay. So we don't need to use one of these in this project, but in another industrial project where there's moving machinery, that circuit that we just went through, that may need to go back to a safety relay to verify that it's in the correct state, it's healthy, it's not healthy. And I think these are just like tested to a very high level, so there's no chance that there's a malfunction which could then lead to someone losing their life or losing a limb or something like that. These are like, if you know what I mean.
All lines.
Yeah.
You said redundancy, the word redundancy. I've heard Chris say it quite a few times. Someone just let me know what that is in basic terms, please. Like, is it used in schematics a lot? Is it redundancy? BMS panels, like.
Go on, Paul. What's your answer to that?
Please.
Oh God, cheers for that. So talking from an industrial process, it's just like different on a safety circuit. It's different. Instead of just having the one channel there, that could go faulty, and you might not be able to trigger the safety when you need it. So basically, someone can get injured, or something could like blow up, or something like that. Things could like go to shit, basically. So you'll have different layers. So you'll have like another. Say if you had the single one running through there, you'd have another cable running through, and I think they go up to quad channel safety circuits. So it's just about making sure that if something does fail, there's another layer of protection there to cover your arse, basically, to stop anything going awry. in a layman's terms. Chris will put it more
No.
put it better than that.
Hey, that was perfect. That was really good. Like, so what, like dual redundancy on this e-stop that we were talking about, like if it is a safety critical system, like this is our e-stop, our physical e-stop with our push button there. Rather than just having, like in this project, we've only got one normally close contact in this e-stop. In a safety critical one, then we might have two. And hopefully the way I draw this won't be too shit. Let's do this one first. So we got, and this let's just say this is going back to that safety relay pilts. So what we've got is we got this circuit and we got this circuit, basically two circuits for the same piece of equipment, same device, and the safety relay is looking for this one to operate in the same way as this one, or it might be that this one's normally open. Doesn't matter, as long as they're sort of switching in unison, that then tells this safety relay over here that component is okay, it's working, there's no sort of damage to it, and it just verifies. It's another layer, it's another, like one circuit is pretty reliable, but because it's safety critical, we need another circuit just to verify that, if that makes sense, Gary.
Yes, mate. So that's dual redundancy, yeah?
Yeah, I would say that's.
So if there was one, would that be called solo redundancy or single redundancy or mono redundancy?
Solar redundancy.
Yeah, if it was just one switch. Paul?
I haven't heard that term before. Solo.
No, it's not so like I say you do. It's I don't think it's really termed like that, to be honest, mate. But yeah, you aren't wrong in what you say.
Let's just define the term, because that might be helpful for us. So let's just type in redundancy. Redundance. There we go. Good old Google. Redundancy definition. Yeah. So redundancy, the state of being not or no longer needed or useful. The state of being no longer in engineering, that's probably a better one. The inclusion of extra components which are not strictly necessary to functioning in case of failure in other components. That's what we're talking about.
Nice one, mate. Thank you.
Yeah. So it's not strictly necessary to the functioning. We can still have this machine functioning on just one of those contacts, because we want to be very safe and sure that everything's okay, then we're adding that additional circuit, normally closed contact, for redundancy, the inclusion of extra components which are not strictly necessary to the functioning, but this is for like in case of failure and other safety measures, basically. Cool. I'm going to call it a day, guys, unless anyone's got any other questions. Great stuff. Yeah, I'll see you on the next train. Well, there's one this evening as well. You're welcome to join me on that as well. If not, I'll see you next week. And any questions in the meantime, just send me a message on, well, hopefully WhatsApp will be sorted in the next day or two. But email, WhatsApp, text message, and I'll get back to you.